Good morning, everyone. Uh, so, as we discussed today, we are going to start with socket programming. This can be a very important lesson to understand the background of networking and also to build security on top of it. So, probably 30 to 40 minutes, I'll be discussing about theory part. Then, as a second lesson, I'll be going into some interesting practical implementations. Right? So, you will see like how these two things merged from learn assembly and then later on we try to merge these two disciplines together, right? So, let's start. So basically, when you think about fundamentals of networking, so when you have two devices, right? When you have two devices, when they want to get connected, so basically you have to have either a physical medium connecting these two, right? So it can be a physical medium like this, so it's physical, right? So if not, it can be even wireless, right? So, it can be over the wire, right? So wireless also can be a connecting medium, right? So if you are trying to narrate this with TCP/IP model, so at the network access layer, you find this physical or the wireless medium, right? And on top of that, you know that you have the what is the other one? So this is physical layer, and yeah. So then you have the TCP or the IP layer, right? And then on top of it, you have the TCP layer, right? And on top of that, you have the application layer. So this is a must for everyone to learn, because without knowing this, is very hard to understand any bit of networking, right? Um, so, we talked about this physical medium in the network access layer, and if you ask this question, what you do at the IP layer, right? So, what you do at the IP layer, and then what you do at the TCP layer are very important questions, right? Mm, so, importantly, the IP layer uh, is doing this best path selection, right? So the IP layer is mainly doing the best path selection. So it's called the best path selection, right? Best path. So probably have heard about this. So that's where you get these things like routing. So routing is basically best path selection. So if you want to go from one location to another location in a network, there can be so many paths, right? So there can be so many paths. So selecting one over the other, so you get the priority. This is the first, and this is the second, and this is the third. So that basically is the best path selection. But do remember, there can be pitfalls here. Uh, so this is our first whiteboard. So I'll share these whiteboards later, right? So best path selection is not always, so best path is not always equals to shortest path. The shortest path is so famous in networking or even discrete mathematics. So shortest path is not always the best path, right? So as an example, you can go from say Colombo to Madara, right, to the highway, right, can be the shortest path. But when there is some trouble in the highway, you might not be selecting even the shortest path, right? So if there's flooding or whatsoever, this might not be the best path. So best path is always the optimal path. So it can have lot other parameters, the bandwidth if it's networking, right? So and so delay and also so many other things to select the best path. All right. So that's basically the beauty of the IP layer or internet layer, right? And when you talk about TCP layer, that's where the socket comes in. So that's where the socket comes in. Uh, yeah. So let me open up a new whiteboard. Yeah. Now in the TCP layer, right? In the TCP layer, So now already the packets are moving from one end to the other end. So A to B, it's already happening. So packets are moving from this to this end, right? So it's moving, so get some sort of reliability, not complete reliability, but with some reliability, you can say that packets are moving. So, but there should be some more reliability in this whole story, right? And also we need other things like safety and all these things. So, and you cannot you can assume that the network layer, the IP layer, does all these things, right? So we got to depends on few other things to make it happen. So that's where the TCP or the TCP layer comes in, right? Transmission control protocol. So it's like sort of a controlling thing, right? Transmission control protocol. So what it does a very beautiful thing, right? So from A to B, it provides a reliable connectivity. Like you call it a reliable connectivity. Uh, Sometimes it might not be 100% reliable, but it's more reliable than the network layer. So to achieve it, it creates this virtualization, right? So it's basically another virtualization. So remember, virtualization is not new, right? Because they are from the days where the TCP/IP or the OSIsoft model started. So it creates this virtualization or this environment. It's this nice little thing called the socket. Right? So it's a socket. So this socket is a virtualization uh, representing end. It's like an end. So one end of the communication. So if you have a one end at this place, you got to have another end at this side, right? So this is our B. So this is also you have to have another end. So this is another socket. So in right in networking terms, this is the source socket. It's a source, right? And this is the destination. This is the destination, right? Right, this is the destination socket. So now you get a wonderful, socket pair. So you get a socket pair. So you have the source socket and the destination socket. So depending on which protocol you use, uh, whether it's TCP or you get a very reliable socket created in between, right? So you get a socket dot. We said like a tunnel, like the VPN tunnel thing, tunnel created. It depends, no? In UDP it differs a bit. You get this tunnel. So then what happens? You put your data in. So this, see, like this step should presume with a networking layer. So then you create the socket. To create the socket, you need to find the best path. So once you set the best path in TCP, not in UDP, TCP, you get this socket tunnel created. So once you put data in, right? So in the queue, you can put the data in, right? So this data moves to this side without much of a problem. So you get sort of a reliability. Right? So the data moves in this wire. Right? So that's kind of a reliable communication. This is a reliable communication. Right? Alright, so that's quite interesting, right? It's quite interesting. So this is basically what you do at socket programming, right? Or you learn at socket programming. So that's a lot more to learn than this, of course. So how do you create this socket? What is a socket, right? And what are the states of the socket? So basically, you have to understand what is a socket, right? So what is a socket? Right? So what is a socket? And then how do you create a socket? So programmatically, so how to programmatically using a program, how do you create a socket, right? How do you create a socket, right? And also what are the states of a socket. So there can be multiple states of a socket. So as an example, if you go and do a net stat, right? So you find sockets, right? So you find sockets and do a net stat minus NA, right? So that's that. Yeah, so these are some sockets. Yeah, you can see. So these are sockets. These are TCP sockets, right? So this is a local address, and this is the port. So socket is basically a IP. So I'll stop this. I'll let it go. So maybe you can find different states. And this is a server. So these are servers. So this is the client side, and then you can see the state. So you have almost, there are several established states. There are so many of them. There's one what about in India? And also there are some other sockets. This is a socket which is in this thing called closed wait state. Closed wait, right? Yeah, all the other things are. There's another one called time wait state. So that's basically how the sockets are represented, right? So almost all of them HTTPS. These are ports HTTPS, which are secure sockets, secure ports. Right? Sorry, 443 to my knowledge, right? Yeah. So there's a one which is different, 5228, and there's another one called IMAPS. Another one 4224, 4244, and 5223. Yeah, and some of these sockets are UDP, so you can see from here on is UDP. Yeah, so at the moment it doesn't make sense, but it's okay, right? And also there are some other advanced type of sockets also, which we will look at later, right? Okay, so that's basically a socket, how it's created. So remember, everything that you do in your computer, right? So the beauty is that end of the day, there will be a socket created, right? So whatever you do watch Netflix, you do go to a website, you do a chat, or you do a streaming, whatever the case, you will find a socket created on the line, right? So when you learn security, especially like if you go into system security, systems programming, network security, or pen testing even, right? You need to understand the underlying architecture. Without knowing this, you are like, uh, just looking here and there. So it's very important knowing this underlying networking technology, right? So of course, but there are these pre-assumptions that you know your TCP IP, the IP addressing, all these things, right? So we have prerequisites, but see, is also important stuff, right? Yeah, and if you now let us this one. Okay. So let us discuss a bit more on sockets. So what is a socket? So what will happen uh, in case of creating a socket, right? Uh, when you have a computer, obviously you have a network interface card, right? So it's the NIC, right? So the NIC would consist of either one or more IP addresses, right? So you are familiar with IP addresses, right? And so you have it in this format: 192.168 0.5 IP address, sample IP address. So once you have IP address, so this is like the base of network communication, right? So this is the representation of the networking layer. So it's like a virtual thing, but we have the physical ones, also the MAC address, but we normally use IP address. It's more friendlier than using MAC. All right. So this is like the normal center point of communication to this point. So of course we have IPv4 and IPv6. Both are in play these days. So in the future probably we will shift into IPv6 completely, but who knows, right? So when you get this IP address, that's knowing like how to communicate or how to identify this particular device, especially this network card, right? So not nothing else. This network card, network doesn't know anything other than the network card. So you go to network card, you can go to the rest of the places. That's the logic, right? Uh, right. So That's basically it. So when you want to connect, like we explained in the previous whiteboard, right? So you need to create this socket, right? So the idea now is when you're creating socket, I told you it's a virtual thing. In your computer, you have to use your IP address. So because IP address is that overall concept that you have to identify anything, right? So so the first center point is IP address. So you have to get the IP, right? You get the IP address. So sorry about right. So you get the IP address, right? So you get the IP address, and then you are using a port also, because if you use one IP address, or if you have one IP address in your computer, you'll probably end up having only one socket. So that's not very usable, and also it's not scalable. So because of that, we use this combination IP address and port. So there are so many ports to select. So you have 65,500 something ports, right? So you are not going to end up getting any less combination, get any number of combinations. So if you have more than one IP address, again you can get many sockets. So we don't have yet a problem of creating sockets. So in the server environment, to facilitate this, we use concepts like netting and patting and all these things. So, so by using these other infrastructure elements, utilities, as we say, we can solve this problem very easily, right? But when you're doing the practice, you understand it's not a big deal, right? So, so this is answering what is a socket, right? So now you know what is a socket. So basically, when you're programming, also you will understand your code base, or your code should be able to create a data structure. Data structure, so struct consists of your IP and also your port, right? Yeah, so that's basically how we create our sockets, right? So this is how we create our sockets. So different programming languages. So we can do socket programming using C. C is like the universal choice. But now we have other things like so for a long time C was like the most used option. But now, of course, there are people who are doing Java also. And now, like or any language is possible. We have Python programmers doing networking, this socket programming stuff, and also Rust and many other languages are there to do this. Right. So only thing is you have to be able to find a feasible language to understand the whole thing. Right. But for people who are being need to learn more on cyber security or security, I would recommend you to go with either C or Python. Uh, Not that other languages are bad or anything, but you get more resources, more books written on this subject uh, using C or Python, or even Shell is also okay. So next level, when you try doing this shell coding or like exploit development, you will find most of these things are written in C and Python, right? So yeah, so that's answering the second question, what is a socket, right? And then we'll go bit into understanding this using a slide. Just give me a second, I'll do the slide. Yeah, no, sorry, not that. Okay. All right. So what you see here is basically a set of slides explaining about the socket program, right? So we'll go ahead. So so this is what I explained earlier also. So we have compute on the net. So you have a lot of hosts like this, and then you have client server computing. So yeah, and then we have client server communication. So client is sometimes on and the server is always on. So client initiate the request, server service to many clients. So client can be anything, your web browser or anything, right? Yeah. So what you do in a socket, it's like end-to-end communication. So the right word would be end-to-end communication, right? So process sensor receives through a socket. So analogy is the doorway of the house. And also there's a nice example that you can take always, which is a phone communication, right? You take a call to one of your friends. So it's the same thing that happens, right? So you have to connect to the provider, and the provider connects to your friend's phone, and it goes on and on, right? So same analogy is there, right? So you can see you have a socket created at both sides. So both sides you need to have the socket. So that's the logical way of understanding this. So here, of course, we also will look at C a lot, C language a lot. So these initial libraries are coming from Unix, right? So Unix OS, you have all these libraries, right? And it's having all these different functions. So there are a lot of functions. See, these are some of those functions. So on the client side, there's a function create, connect, write, read, close, and server create, bind, listen, accept, read, write, close. So that's plenty of functions to create the socket and communicate with the sockets and all that. Right, so the socket interface is a collection of system calls, right? So you'll understand like these are system calls. And the initial packages was developed from Berkeley Unix, and then this is adapted in many other operating systems. So wherever you go, whatever Linux or different operating system, you will find these system calls, socket interfaces. So remember, C you have it, and Java you have the socket interface, but specifically this one talks about this C API, right? And then you have to know a bit about Unix also. Unix, everything regard to be as a file, right? So it works as a file. So it has input is reading like a reading a file, output is writing to a file. File is represented by an integer with a file descriptor. So descriptor is simply a name, right? So uh, yeah, so that's basically what I mean by a descriptor. All right, and file is okay. Data written into socket on one host can be read by other sockets. So it's like the tunnel that I explained. So the tunnel, right? So you have a tunnel. So when you write from to one side, you can read from the other side. So that's the whole logic. Yeah. So we move on. So how to create a socket? So I told you we have IP address and the port number, right? And why do we need to have a port number? Because I explained. So if you just use the IP address, you will have limited options, right? Limited options. So that's the real reason why you need a port, right? Right, so this is example where in a server you can have different ports for different services, right? Different ports for different services. So as you see here, port 80 is for web service, right? On a web server. And you can get port 23, port 21 for these all well-known services like Telnet, FTP, and all these things. So I believe you are aware about these things, right? So that's the same logic we can apply. So when you want a socket for your web server, you can use port 80, right, at the destination site, right? And when you need the socket for Telnet, you can get port 23, yeah, or port 21 for FTP, I believe, right? Yes. So that's what you do. Right? So as an example, the service request comes as the IP address, and then port 80. It says simply that you want to go to this particular computer and then you want to connect to the web server, right? So yeah, so that's the logic, right? Okay, and then second example, echo server, right? So we actually will be implementing this echo server. It's quite famous example in socket programming, so we'll be learning that as well. Right. And then socket connection has 5 general parameters. First, the protocol. So that also we talked about. TCP is the reliable protocol, whereas UDP is the unreliable form of it. And then you have IP address. So you have to define the protocol. So even in our uh, example, we have seen the same parameters: protocol. We have receiving and sending packets, and also local address, foreign address, and the state. Right. So similarly, you get the IP addresses. Right. And then you have the local and remote port numbers. So ports are also important parts of a socket, right? And some ports are reserved. Now port 80, it's not recommended to reuse it because it's reserved. So reserved ports should not be used for any other purpose, because what happens would be you'll have a lot of conflicts. And root access required to listen on port numbers below 1020 because they are called well-known ports. So if you want, you can override it. There is a possibility that you can override it, uh, but you need the root access to do that. Right? All right. So this is a client program, typical client program. Prepare to communicate. You have to create a socket from your side. You have to create a socket. Determine server address and the port number, and initiate the connection to the server. So the server side. Uh, write the data of the socket, read the data from the socket, so and close the socket. So this is the basic um, communication that you do. Right? So this is what you do from client to server. Right? So this is a client program, right? And then from the server side the other way. So we'll look at from example later on, to a graphical example, so that will be more convenient to understand. Right. So to do this, you use these particular functions, set of functions. So the more important function is the socket function. So socket is the function which creates the basic you call socket functions from both sides, so then both sides you will have a socket created, right? Yeah. So my net connection is getting slower. Yes, so you have the socket function created. So you get two sockets. And then what you can do is, this is a client side. So this is a client. So this is the client and this is server, right? This is server. Yeah. And then from the client side you call the connect. Right? So your client side you call the connect function, right? So once you call the connect function, it's getting harder. So then what happens is you get the connection created from client to server, right? So the client should call the connect. So socket is basically, server socket is basically listening. So I'll come back to this when my connection is okay. Right, so I'll start with the lecture again. So I'll come back to this, right? Right, so you call the connect, right? And then from the server side, you call a few other functions which we'll learn later. And once that connection is created, you can do reads and writes. And then you can do the closing, right? So very important, like as any good programmer, you have to, once you create sockets, you have to close them, right? So you are using resources, you have to close them. Like if you use a Java socket programming, this might not be a big issue, but otherwise yes. So yeah, so then so this is the function. So this is a C function. So you have the socket function. So you have to set these parameters: the domain, the type, and the protocol, right? So it returns a descriptor. It's just a handler. So it's like a pointer to a file, right? And then if we discuss what is the domain, domain is a protocol family. So it can be IPv4, IPv6 likewise. So this is PFINet. So you represent this from PFINet. And then the type is either sock stream or sock datagram, meaning it can be either TCP or UDP, right? And then yeah, so then you have to use specific protocols, right, inside the protocol section. So these examples provided. So you have PFINet. So this might not change, but in TCP you get sock stream, and then you have sock datagram or datagram in the UDP example. So this is a very simple way of representing a TCP IP. So TCP UDP sockets. So it's not hard to understand how to create a socket. And then you call the connect function. So on the client side, you have to connect call the connect function. Right? So they again use a descriptor which was written from the early example. So this is the socket descriptor. So this is like the point, center point of attraction thereafter. Everything will be connected and handled by the socket descriptor. So that's why you can see the socket descriptor is part of the connect function. And then you send other details like the IP address and the port number. And of course, when you talk about language like C, you need to understand your scoping of your variables. So you have to use pass the address length as well for a structure. So we talk about those things later, right? So the arguments are socket descriptor, server address, and the size of it. So there are three things, right? And the remote address and the port are in the socket address. So the socket address structure, this one, consists of all the details, right? Type is stuff like that. And return 0 if in success. So it also returns integer. So it returns integer. So if it is 0, it's a success. If it's a -1, then it's a error. Right. So then there are the few functions. So you have the write function and the read function. So to write and read. So remember we talked about this tunnel, nice tunnel, right? Can I go here? Yeah, no. Right. So there, after you set up that connection, it's basically writes and reads. So again, remember, see, all the time use a sockfd. That's the center point of attraction, right? It's very neat, right? And then finally you do the close up of the socket. So as a good programmer, you always do the garbage collection, right? And again, these functions also written the number of characters written. So if you write number of bytes, that will be the returning value, and -1 of error. So receiving, it's not like sending, like a writing part. Reading returns number of characters read, again -1 if it is a error. So knowing these functions in and out can be very useful as a programmer, as a security programmer, as a pen tester, as a networking guy. So all these things are quite useful. All right, so we'll come to this later on, the Big Indian and Little Indian. All right, so then thereafter, to understand this, we might have to look at the practical. So in this lesson, what I'm planning to do is to give you a bit of example. Then the next part of the lesson, I'll be taking you through a real practical. So yeah, I'll show you a quick example. Yeah. All right. No, what I'll do, I'll come back in the next session, and I will do some practical work. So for the moment, check on this, uh, and we can look at the practical component in the next part, and then come back again and go through this Little Indian, Big Indian, and the rest of it. All right, guys.